Hello everyone. Today we're going to be looking at p-values, and the p-value is the one which will help us to figure out whether to reject or accept or fail to reject the null hypothesis. So once again, we are going to be doing a quick recap of things we have learned. We're going to look at hypothesis, the analysis, and we're going to look at in this session specifically the concepts which are needed to develop the procedure for hypothesis testing. In other words, the test statistics, p-value, and how to make conclusions from there. Okay, so once again, it's a simple recap. A significance test is a test which helps us in making a statistical inference about a claim relating to a population characteristic. And it tells us whether the claim which has been made is plausible or not. And we use sample data which has been randomly generated to summarize the evidence about this hypothesis or the claim. Now, there are two kinds of hypotheses: the null and the alternative hypothesis. The null hypothesis, I hope you are now more comfortable with this by now, is denoted by H sub 0. It is assumed to be true, and the alternative hypothesis is a new idea which challenges the status quo. Okay, how do we represent that? The key points are, whenever you're having a null hypothesis, you always should have an equal sign and you will have a parameter on one side. And then the other side is going to be the numerical value or the hypothesized value. The alternative hypothesis have three possible scenarios: when the parameter is strictly greater than, called a right-tail test; when the parameter is strictly less than the hypothesized value, the left-tail test; or the parameter is not equal to the hypothesized value, you have a two-tail test. A quick example once again, we're going to look at the mean area of apartments in a new development, which was advertised to be 1250 square feet. And a tenant group thinks, oh no, the apartments are too small. Okay, here's the key point: small and mean square feet. So what they do is they have a suspicion, they hire an engineer to measure a sample of these apartments. So what would be the null and the alternative hypothesis? Now remember, the parameter is mean, so that means you will have mu equal to for the null, and for the alternative you'll have a mu. Now, what is the hypothesized value? Is the one which was advertised by these apartment people. That's 1250 square roots. And that's what's also going to be in your null. But the thing is, what is the sign you will use for the null, the alternative hypothesis? So remember, the highlighted part smaller than, that's what is going to be reflected in the null hypothesis. Now, to keep in mind, when you make these the claims are made, the whole idea of these hypothesis testing is which one is better. Is the null hypothesis the right one, or the alternative hypothesis the right one? So what you're basically doing is we use a sample to say whether the null hypothesis is false or the null hypothesis should not be rejected. So there are two possible conclusions coming out of it. Either we reject the null hypothesis or we fail to reject the null hypothesis. Now, in order to do all these things, we need to have a test statistics, the one which will help us make that decision. Okay, so what is a test statistics? A test statistics is the quantity or the function of the sample data on which the conclusion to reject or fail to reject the null hypothesis is based. So this is the key component on which our decisions are going to be made. What does actually it do? A test statistics describes how far the observed sample statistics falls from the hypothesized value given the null hypothesis. So basically it says is, I have a null hypothesis which has a value and which has the hypothesized value. And when we take the sample, we would like to know how far that observed sample statistics is away from that hypothesized value, given that the null hypothesis is true. Remember the word given, that's an important catch here too. Now, if this test statistics falls very far from the value suggested by the null hypothesis in the direction of the alternative hypothesis, which is a strong evidence against the null hypothesis and in favor of the alternative hypothesis. Now, before we can do all these testing work, we have to make sure the assumptions of the test which are used are true. And that we will see in further video sessions too. So let's look at, so we have got the information, we need to test statistics. And now we're going to talk about the major fact called the p-values. Okay, what is a fundamental step? This is a key part, guys. The p-value is the key part for us. A very fundamental step in hypothesis testing is, if I take a sample and I get a very unusual answer, given my null hypothesis, that is going to start to make me think. Remember, if we get an answers which are as the usual normal answers, as they, oh, nah, nothing is okay, everything's fine, But if you take a sample and something weird kind of data comes up and I say something is not right, you have that feeling with you that what is this unusual thing popping up? Something is not right. And that's the key thing for us, is the finding the probability of seeing something unlikely to happen given that null hypothesis is called the p-value. This p-value is the one which says, oh, something is not right, that something is really unusually happening given this claim we had made. And when that pops up in our sample data, we got to take care of it. We got to notice that. And that's going to be a very important step in our analysis. Now let's go and look at the proper definition of these p-values, okay? So, a p-value. A p-value is a conditional probability. It tells us the probability of getting a result at least as unusual as the observed statistics given the null hypothesis true. This observed statistics, guys, is something we will look at it further too. So it's the observed statistics which is coming from your sample data given that the null hypothesis is already present. So what you're thinking of a p-value here now is, it's a measure of inconsistency between the hypothesized value for the parameter and the observed sample statistics. So if the hypothesized value and the observed sample are too far apart from each other, given that the claim, which is the null hypothesis, is true for us, starts to make us think. And that's where p-value comes in place. For example, if I say p-value is 0.03, that means 3%. Nah, it's not a big thing. It's not that far off, Given that the null hypothesis, what this simply means is that they're given a null hypothesis. You see the word given? Given, remember, means you will have conditional. So it's given the null hypothesis, there is 3% chance of observing the statistic value that we have actually observed, unlike the null value. 3% is no, it's okay. 3% is not that bad. Now, what do we do with these p-values? Now, I have explained this, initially, and I will just go with you again. So what this p-value is, if your p-value is very high, it means something is, it's like the ordinary, it's not so surprising. It's as usual happening. These are kind of things which keep on happening all the time. Like, every day the sun will set, the moon will rise. That's normal. That's going to happen. There's no reason it's going to affect our null hypothesis. It's that kind of scenario. So if the p-value, very big picture, if the p-value is very high, that means nothing unusual happening. Our null hypothesis is fine. We do not have to reject our null hypothesis. But if my p-value is very, very small. So that means it is like 0.01 or say 0.001. Very small, 1%. It's like 0.1%. Something is unusual in our data set. And when something is unusual, we all think, what's going on? Remember that? And we are always, as human beings, we're very suspicious of these rare events. So if the data comes out to be rare, that's when we say we are going to reject the null hypothesis. So what is the combination? If you have a very high p-value, say, 3%, 5%. Nah, that's nothing. It's a very high p-value. It's okay, it's fine. Okay, but if the p-value is very small, 0.1%, 1%, something is not right. Okay, so then we reject the null hypothesis. So this rare event is by setting up a threshold. This rare event is done by setting up a threshold value for a p-value, and that is called the significance level alpha. And most of the time it is 5%. That's what we normally take, 5%. If it is less than 5%, yeah, something to think about. But like if it is say 1%, 5%, so those kind of things here. So if it is say 5%, then 3% will be something unusual. But if it is 1% is the alpha, then definitely 3% is not. It depends upon what that significance level is, and you will be given that in your problems. Okay, let's look at from a graphical point of view. How does it look like to us? So this is the sampling distribution of the test statistics. Remember that. A sampling distribution. We've done that, guys. You take a sample set and you look at the distribution. And so the sampling, because if you take a random sample, it will have a probability distribution, means and standard deviation. So it's a sampling distribution of the test statistics. And remember we have done the sampling distribution of the sample mean and sample proportion. So those are the things we're talking about. So his is the H0 value. And that's always, we're assuming, here we're assuming it's a normal distribution. That's why I'm taking it over here. So the H0 value is basically your, say, the average. It's the mean of the test statistics. It can be, and then we take a random sample. That's the random sample value, say. And if the p-value comes beyond that, so these are some extreme values. P-value is the probability. That means it's the area under the curve. Keep that in mind. And it's a conditional probability. So what we see in the above figure is, so this is a sample test value, and if suppose we take another value, and the p-value is the probability that the test statistic value is like this observed one or even more extreme, that is basically this little shaded area, then we will say, this is little, not right, so we might end up rejecting the null hypothesis. So let's look at this little simple example, which would give us stronger evidence against the null hypothesis. A p-value of 0.2 or a p-value of 0.01. Now, 0.2 is basically 20%, right? That's not going to give it's a big value, whereas 0.01 means 1%. Now, definitely 1% will give us stronger evidence against the null hypothesis. That means this p-value is indicating something unusual is happening with that test statistics, given that the null hypothesis is true. So finally, once we have calculated our p-values and everything, how do we make our conclusions? So what we normally do is, in the problem, you will be given the significance level alpha. You will know by reading the problem what is the null hypothesis, and then you apply the appropriate method, and you get the p-value. If you get the p-value and the p-value is less than or equal to alpha, that means you have to reject the null hypothesis. But if my p-value is strictly greater than alpha, we fail to reject the null hypothesis, or we do not reject the null hypothesis. Let's look at some examples. So using the definition of p-value to explain why the null hypothesis would certainly be rejected if the p-value is 0.0003 at a 0.05 significance level. Clearly, 0.0003 is very, very far off from 0.05. And what we just learned is that if the p-value is strictly less than the significance level, that means these test results are very unlikely to occur if the null hypothesis is true. And hence, we reject the null hypothesis. Because remember, anything which is unlikely to occur raises a question in our brains. Okay, so last example. For which of the p-values will the null hypothesis be rejected when performing a level of 0.05 test? Clearly, 0.001 is less than 0.05. That means, yes, the null hypothesis is rejected. What about 0.148? Nah, it is bigger. So the answer is no, we are not going to reject it. What about 0.078? Nope, it's greater than 0.05. No rejection. What about 0.021? Definitely less than 0.05. Yes, the Ch9 is rejected. Okay? Thank you, guys.